All right, so let's say you have an expertly drawn and very artful cylinder with a movable piston in it, and I've put a gas on both sides. Specifically, I have 2 moles of gas on the left side and 5 moles of gas on the right, and you can see it's the divisions of the length. So let's say that the diameter of the piston is 5 centimeters, and that the length of the piston is, let's just say 20 centimeters. So, and we'll say for part A, we are going to assume that temperature of the left is equal to temperature of the right. And we want to find the initial force on the piston, the initial net force on the piston. Of course, once that piston starts moving, that force will change. And then for part B, which I'll write out in a little bit, we are going to assume that they do not have the same temperature on both sides. So for part A, what we are going to do is I need to figure out the force from each side. So I need the pressure to figure out the force, right? I know that pressure equals force over area. So this tells me that force is equal to pressure times area. So I need to figure out both the pressure and the area. Well, the area is easy because the area on the piston, because that's what we're talking about, is equal to pi r squared, or we could write it as pi times d over 2 squared, because what was given is the diameter. And it's going to be important to convert this to meters, just as a reminder. So now how do we find the pressure? Well, to do that, the pressure, we have to define a temperature too. So we have to say that we'll say TR is equal to 300 Kelvin. I like 300 Kelvin pretty well as a number because it's room temperature-ish, but it's also a nice number. Okay, so to find pressure, we need to say that PV equals nRT, and we're going to solve this for pressure. So this tells me that pressure is equal to number of moles times the gas constant times the temperature divided by the volume. Okay, so now, but what's the volume? Well, we're going to need to figure that out too, I guess. So what is the volume of a cylinder? Well, the volume of a cylinder is equal to the area of the cap times the height, right? I guess I could have just written H, but whatever. So I could write the pressure then as nRT over AL in this case. So now when I go to find the force is going to be, once again, as a reminder, pressure times area, but pressure is going to be nRT over AL times area. So that cancels with that. And so our force is going to be nRT divided by the length in this case. Oop, I wrote that where you couldn't see it. I told myself I wasn't going to, but I did anyways. So now for part A, all we have to do is put those numbers in, and I'm going to pause it and do that on the side. Actually, that's not all we have to do. We have to take care of something else first, because that's just an individual force. We never actually drew a free body diagram. So we should actually have, when we draw this, we have our piston. Right, so you're going to have a force from this side, I'm going to call it FL, and a force from this side, FR. So when you have this diagram, of course, I'm going to have to take the net force because we're looking for. So I need FL minus FR. So FL because it's the force from the left side, right? And FR because it's the force from the right. So solving this for the net force, and so I have to solve each of those individually. So now I'll pause it and then come back and let you know. All right, so I've done a bit of extra stuff here. So I've put in the numbers for FL. So it was 2 moles times 8.314 joules per mole Kelvin times 300 Kelvin over the length of the left side, which is 0.05 meters. Don't forget to convert that to meters. Now on the right side, it's basically the same thing, except I have 5 moles and 0.15 meters because it's the remaining length, right? So then I put the numbers in here to find my net force, and all I have to do is subtract them. Now I know, I push the subtract on here because I haven't done that yet. Well, some of you who are pay a particular attention and care about formalism will notice I use more significant figures here than was given in the problem. And that's fine because these aren't my final answer. These are just an intermediate step, so you can keep more answers during the problem. Just report your final answer to the specified value, or to specified number of significant figures. So minus 83,140, which tells me that my net force is 16,600 newtons. Now I know what you are also thinking. Why is it so big? Why are they such extremely large numbers? Well, to remind you, if we look at this picture, and from a previous video, maybe I used too many moles in each side, but we have a pretty small volume. We're talking 5 centimeters diameter by 20 centimeter length in total, and I have 7 moles of gas in here. Now, if you remember at standard temperature and pressure, which we are at standard temperature but not pressure, you would find that you have 1 mole of gas would take up 22.3 liters, or 0.02 meters cubed. So let me figure out the total volume we have is real quick. So we have, let me just pause it while I do that. Our total volume is actually going to be, pi r squared times length. And when you calculate it, it is 0.00123 meters cubed. And I'll remind you that 1 mole of gas takes up 0.0224 liters or meters cubed at STP. So that means we are a significantly smaller volume and significantly more gas. So that makes sense that we have lots and lots of force on both sides. All right, so I'm going to get a new paper and we'll do part B. So part B, we're going to do pretty much the exact same problem, except we are going to assume that the sides of different temperatures. So I'm going to say that TL, the temperature of the left side, has a temperature of 200 Kelvin. So significantly colder than the right side. But everything else is going to remain the same, and we're going to look for the net force. So I can just steal stuff that I did before. I can say that the force is still equal to nRT over L, right? Because getting to there is the same thing. So I'll say that part A tells us that, stealing that from part A. So now what I need to do is figure out how that temperature affects things. So I'm just going to go ahead and calculate the forces for both. Be right back. So those of you who are more astute than I am would have realized that the only number I actually changed is I changed this 300 to 200, which means I could have just taken this value, multiplied by 2/3, and the force for the right hasn't changed. So doing my net force, I'm going to still say FL minus FR, because I want things going to the left minus things going to the right. So that's going to equal 66,512 newtons minus 83,140 140 newtons, and that is going to get us a value of, for the net force, minus 16,628, which we should actually round to 3 significant figures. I think all my problem things were fewer, but I'm using 3 because that's pretty standard for AP. So I'm going to say minus 16,600. And yes, it is just kind of a fluke of the numbers that happen to be negative of the other one. Just because of the ratios I picked. If I picked a different temperature or different numbers of moles, it wouldn't have worked out the same. Yep. That's it for this video, guys. Hope you are making good life choices and keeping safe out there. See you later.